Hello everyone, my name is Yi. I'm from New Jersey Institute of Technology. Today, I would like to introduce our poster with the title Improving Automated Program Repair Using Two-Layer Tree-Based Neural Networks. This research work has been done by me, my supervisor Dr. Shaohua Wang, and Dr. Tin Yuan from the University of Texas at Dallas. Recently, various automated program repairing, we call it APR tools, perform automated repairs using distinct ways. While the deep learning is getting more and more popular, it is also being used in many approaches for APR problems, like coded, ratchet, and so on. But existing deep learning-based approaches all have some limitations, include that they have a hard time to find the correct fixing location in a buggy statement. They often use sequence-based representation to deal with the code, but in fact, the code has different structures than the normal natural language. And they cannot learn the information from surrounding code to help fix the buggy statement. To overcome these limitations, we come up with our approach DL-Fix with the following contributions. Firstly, DL-Fix is the first deep learning approach that generates complementary results comparing with pattern-based tools. Secondly, DL-Fix has a new two-layer model to do the surrounding code context and transformation learning separately. Thirdly, DL-Fix can fix at least 2.5 times more bugs than the best performing DL approaches. As for DL-Fix, there are 5 main steps. The first step is the preprocessing step. We firstly generate abstract syntax trees for all buggy methods, and then we do alpha renaming for all code tokens in order to make our model is general for all different code and data. And then we generate the code representations for each code token in order to embedding the abstract syntax tree to vectors for the model to learn. Next, we select the subtree that can represent the buggy statement as the buggy subtree. At the same time, we use the deep learning approach to summarize the buggy subtree into a node, and then we replace the buggy subtree in the original abstract syntax tree by that node. The new tree, we call it a tree with the summarized node. As for the step 2, we use one tree-based RNN as the local context learning layer to learn the local context of the code. More specifically, we use the tree with summarized node as input for this layer to learn the new summarized node vector, which can be used as weight for the next step. As for step 3, we use the other tree-based RNN as the code transformation learning layer to learn the code transformation changes. More specifically, we use the buggy subtree as input and use the learned summarized node vector as the weight added to the input. By using the tree-based RNN model, we can generate the fixed candidate for the buggy subtree. As for step 4, we build some program analysis filters to help reduce the candidate amount in order to improve the model performance. As for step 5, we use a convolutional neural network-based classification model to re-rank all candidate patches in order to improve the accuracy of prediction results. In order to evaluate our DL-Fix performance, we compare DL-Fix with state-of-art pattern-based APR approaches, and also we compare DL-Fix with state-of-art deep learning-based APR approaches. We evaluate approaches on Defects4j, Box.jar, and BakeFix, 3 datasets. Our experiment results shows that DL-Fix can auto-fix 30 Defects4j bugs, while the best performed pattern-based baseline, SameFix, and T-bar can fix 34 and 43 bugs. DL-Fix can fix 11 and 7 unique bugs when comparing with these two tools, so which proves that our approach can have comparable results with pattern-based APR approaches. Also, our results shows that DL-Fix can fix the most bugs in Defects4j, Box.jar, and BakeFix by using only top 1 ranked candidates when comparing with other deep learning-based approaches. DL-Fix can fix at least 2.5 times bugs than the best performance baselines. As a summary, in this poster, we show DL-Fix, a two-layer deep learning-based automated program repair approach to improve and complement the existing state-of-the-art APR approaches. This is all about our poster. Thank you for your listening.